All right. So today, Dr. Tony will not be available today under some medical conditions. So I will take care of the lecture for this week. Hopefully, he will be back next week. So today, our plan will be like this. We're going to review array a little bit, and then we're going to talk about files, which is my favorite topic in computer science. And we're going to talk about some basic operations on files, such as read and write a file. And between that, we're going to have a little bit administrative break so that everyone can refresh the mind a little bit. And if we have time, we'll cover the bonus topic, but we'll see how it goes. So for array, it's a collection of items residing in memory. An array has a fixed size. You must and it have a clear type in it, and every item in an array must have the same type. So to declare an array, you need to specify a type and give the identifier of the name of the array, and you must have the curly square bracket to indicate that it's an array. It's not a single variable. So. But declaring array does not really give you an array. You must assign something to it. So you will need to use the keyword new and specify the type, which has to match the type of the declaration statement, and then give a specific size. So for example, you say you will declare int array age of students. You will want to assign it, saying it's new int, let's say 50, so which means this array can contain 50 integers. So to initialize an array, it's basically a combination of declaration statement and assignment statement. So as you probably have known already, and one important thing, array cannot be resized, means that once you declared and initialized, it has a fixed size while the program is running. But it can be reassigned. So in this case, I start with my grocery list, and I make the array size of 20. And then during this part, I give some code, say, for example, I assign the first item as apple, the second item as pear. And then later I figure out, okay, well, I don't have much space in the array, so I need a larger grocery list. So I assign a new array which has 40, which can contain 40 items in it. However, if I have ever had any data in this array before, this statement will reset everything. So it will start with an array that has no string at all. Okay, so how array looks like in memory. So we have a declaration statement, which is the left side of this equal sign, let's say int minus. You actually give a reference here. So this is what the declaration statement do. It's give you a pointer that points to an array. That doesn't give anything. Unless you give this right side part, which is 11, 23, 5, and you created an array that tells the computer what exactly int array minus is. And in order to access individual elements in an array, you need the index to refer to it. So the index is based on 0. So you start with 0 and all the way to the end. Yeah, that's pretty much it for array. Multi-dimensional array, I don't think we covered this very much. It's basically an array that contains arrays. So it does not limit it to two-dimensional array, which means it's one-dimensional array that contains multiple one-dimensional array. So the most basic multi-dimensional array is 2D array. So you declare it with two square brackets, and you skip the first dimension in the assignment statement here. And then for the second dimension, you need to do another set of declaration assignments. So for instance, I say in this one, I give the first element of the 2D array as a 4D array, 1D array that has 4 elements in it. And same thing for this one. So what does it look like? It looks like this. When you declare a 2-dimensional array, you first give a pointer here, which points to 4 empty spaces that points to nothing. So that's the declaration statement of the 2D array. And then when it says new int 4, it gives this part, but doesn't give anything here. In the second line, say my matrix 0 equals new int 3, which did this part, gives the 3-element array to the first element of the multidimensional array. Hopefully this all makes sense to you guys if you read the textbook. Let me know if you have any questions. Feel free to raise your hand. All right, so now we're going to talk about files. Very exciting. So let's take a look at this code. I declared an integer variable, saying it's total registration 100, and then I make an array which is string array that has 100 elements in it, and for each element in it, I want to get the input from user, and from the input, I get input from user and assign it to the corresponding position in that array. So my question is, when the program terminates, where is our data? Suppose I declare this I write this program, I enter the 100 students' name to the program. What will happen if the program terminates? Where is my data? Does anyone know?
Nowhere?
Yes, it's gone. Even if I write down 100 names in there, when the program ends, it's gone. It's all gone. You will never get it back. So, but while the program is running, it's in the memory. But when the program ends, it's gone. So clearly, memory is not the place where we want to save our data, especially for reusable data. So the solution is we need to save data on disk instead of memory. So when the program is running, all the data operations, almost all data operations, are in the memory instead of on disk. That is because memory is way faster than disk, while disk has larger capacity, but it's way slower. Memory is usually considered as a volatile storage media, means it only contains things when the power is on. If the power is off, there's nothing left in memory. Everything is reset. So, so what is a file? So when we store things on a disk, we need to store them in some sort of format. And a file is a solution. So file is an abstraction of a sequence of characters on a disk. And it's also an abstraction of input and output of the computer. So when you type something on your keyboard, or you use the mouse, move the mouse cursor around the screen, you're actually writing a file to it, writing something to a file. File can be stored on disk, it can be in memory, it can be accessed by many programs. So for example, you have a Microsoft Word document, you can use Microsoft Word, open that file, you can use something like LibreOffice or probably Apple Work things, those programs. So multiple programs can access the same file. The most important thing I want you guys to know, but I don't think it will be on the exam, is that everything on computer is a file, which means our data, such as your CSV data color delimited file, your Word document, your PDF document, your movies, your music, your pictures, and all the devices, such as a mouse or the screen. Let me do a demo here to show you what kind of file it looks like. So in Linux operating system, and maybe Mac as well, I'm not sure about Mac. For Linux, you can actually look up the devices file in this directory. And as you can see, in this directory, which is /dev/input, I have those files, mouse 0, mouse 0, mouse 1. What does that mean? If I want to display something, if I want to display the file in this terminal, I'll use this command, cat, and of course this require my password because it's a system file. I'm not supposed to access it. You don't see anything right now. However, pay attention to my mouse cursor. Oops, probably not this one. Let's see. Okay, so here. If my mouse cursor is not moving, it's hover there, it does not read and write anything. However, if I move my mouse to the right, to the left, go up and down, the computer receives something and it's written to a file, and the operating system will read what is written to this file and interpret it and write it to the display, and that's what you see when the mouse is moving on display. Of course, you don't need to know this. You will know more about this in the operating system course. Right now, I'm just showing you how file is look like and how file is used in the computer. All right. So we mentioned that file, it looks like it's a stream of characters on disk. What do I mean by that? This is how it looks like in the disk. So for a file that only contains these characters, we have already written this kind of thing all the time, it looks like this on the disk. We start with character U, character S, ing, and the white space character, and then we have an SYSTM, and new line character, and public goes to the second and inner side row, and then class, things like that. So when the program is reading a file, it will read this file as a stream. So we'll start from U and reading all the way to here, and then go to the inner side of the circle and read another loop, and then go to the inner side of one. So as you can, that's why it's called a stream, because it's read one character at a time and load to a buffer. So there are many format of files, but in this class we're only dealing with one kind of file. It's called text file. It's very basic. It's used in many operating systems. It's cross-platforms. Windows, Mac, Linux can all recognize text file. Text files are generally encoded in ASCII characters. So most computers, especially hardware, support these representations. So that's why it's also cross-platform. So text file is not like a Microsoft Word document. You have line spacing, font size, all the color, fancy things. It's only plain text. There's no format, there's no color, and the benefit of this is that you don't have to deal with all those metadata of a file. So examples, such as the files such as the program you're writing so far, .cs file, .cs project file, they are also all text files. All those like program source code, Java, Python, C++, and your data files, such as your CSV, .dat files, web pages, very typical text file, and user preferences, but they're mostly hidden from you. But if you really want to look into it, you can find them in your home directory. So, file operations. What can we do on a file? So it turns out there are two basic operations. We can read a file and write a file. So what will happen when we read a file? So first thing is, because files are stored in disk, in order to access them, we need to load them from disk to memory. And then we can access the file by reading them line by line, especially for text file. It's very easy to do that. And yes, you can read that from the last line to the first line, but it's tricky, and I would not recommend to do that. And for writing a file, what you would do is, first thing is you want to create a file object in the memory. And then you write something to the file in memory. And once you're finished, the operating system will take care of the rest of the work to put the file from memory to disk. However, if you write a file that has the same name in the directory, the old file, or the file that is currently residing in the disk, will be replaced by your new file. So be careful with that. You cannot read and write a file at the same time. It's a very classical problem in an operating system. You will know more about that when you take the OS course. But right now, you just need to know that.
I have a question about that.
Yes.
What do you mean when you say that?
So think about this. You say, when you say,
Wait, can you read it first?
yes, you can read it first, close it, and then write it. Or you can write it, then close it, and read it. You cannot do the same simultaneously. You may say, okay, well, I have been doing like things for my life. Like I open a Microsoft Word document, I read it in the Microsoft Word, and then I can edit it. It seems like you can read and edit at the same time. Actually, it's not. You're just editing it. You're not reading it at all. Well, actually, you read it first, and you're just mostly doing editing. And the Microsoft Word application interprets what happens in the memory to a graphical way that makes you feel like you're actually reading and writing at the same time. Okay, so what do we need to do to read a file? So first thing is we need to know where the file is. We can do that by finding the file path. You can do it manually, which is not hard, or you can do it in the code. And one important thing is you must know the file extension. But for this class, since we mostly are dealing with the text file, so most of the file extension will be in .txt. How do we read a file? How do we write actually in a program? So first thing we need is we need to create a stream reader object that is already implemented by C#. We don't need to worry about what it is. To create a stream reader object, we need to use a new stream reader constructor to create that. So for instance, I want to read the file called myfile.txt. What I will do is I'll declare a stream reader as our first, and then I use this constructor to create a stream reader object and assign to it. And once we have the stream reader, we can start reading files. So the common method that we're going to use is called .readLine method. So which will return a string. For example, given that we have a stream reader object, we can use this method called sr.readLine. This method returns us a string, which is the first line of this file, and we can assign it to a string variable. Once we finish reading the entire file, or you just want to read the first line, but anyways, you want to close it before your program exits, or you think you finished reading the file. Why is that? Well, if you never close it, your program will constantly hold that file. And what will happen is that other programs cannot access that file. So, especially in some operating systems, you can only have one program access a file at one time. So you should use the .close method to close the stream reader once you finish reading the file. All right, so how does the code work? We need to see some code in order to learn how the stream reader works. So I have a program here that let's see where it is. So I have a program that can read any file, any text-based file, and print it out in this console. So what I have is fread. So for example, if I want to print out what this fread underscore demo.cs file is, all I need to do is to start my program and give the argument here and print out. So this is a program that I wrote for this demonstration. So it's a program printout itself, nothing interesting. So the let me see. Okay, the same. Okay, so what I have done here is besides of the using system library, I also need the using system.io library in order to do all those stream reader and stream writer. Oh, whoops! This is file write. Oops, that's not what I want. File read. Yes. Okay. So I need to import this library before I start doing anything, and this is command line argument. You don't need to worry about it right now. So I get the file name, which is a string from the command line argument, and I create a stream reader file object, and then I have this statement: while not sr.end of stream means that as long as there is characters in this file, I read a line from that file and assign to a string variable, which is line, and then I print out right away. And once we reach the end of the file, which means this part will be true, or which means this part will be false, and this while loop will end, and we close that file. Pretty easy, simple. And of course, by the way, all these programs I will upload on Sakai after this lecture, so you can kind of like take a look and tweak it a little bit. Any questions? Is this like all clear to you guys? Is this all clear? Okay, good. So what we need to do is we need to locate the file path. We'll talk about that later in this lecture. And we need to declare and initialize the stream reader object for the file. So in this case, we have this stream reader as r.new stream reader, something like that. You can use a different file name to replace my file.txt. And then, while there are still more lines in the file, we read a line as a string from the file, which we used was sr readline, and assign it to a string variable. We assign it to this string.line, and then we print it out. That's what my program was doing. And of course, after that, we need to close the stream reader object, and the program will end. So my question for you guys. Before we have seen this console.readline method, which we read an input from the console. And now we have this sr.readline method. Where does each them read from? Are they reading from the same thing? Same place? No. console.read line only read input from the console. That means you have to enter something from the user instead from disk. However, SR.read line, suppose SR is a stream reader and we already declared and initialized, it can read any arbitrary file that exists on disk. So it's just basically different mechanism for a computer. Is that sometimes you want to read input from user, but sometimes you want to read input from disk. They're all doing the same thing, reading input from some external data. All right, now let's take some administrative break. Catherine, do you have any announcement?
The only thing I want to say is that I'm behind on grading, so I'm sorry. I'm not able to log in this department. I'll get on with that.
Anything about exam or like incoming homework? Okay. All right. Well, that's really short break. All right. Now we just resume our lecture. How do we modify a file, which also means how do we write a file. So again, the first thing is we need to know what file we want, right? So we need the file path. Of course, you still need to have the extension of the file, otherwise the operating system has no idea what you're doing. And then for writing a file, we use a different object, which is stream writer. And it's also in the system.io library. What we need to do is we need to use this new stream writer constructor to create a stream writer object. And then we assign it to a stream writer that we declared. And then once we have this stream writer object, we can start write things to this stream writer. And the stream writer will save what you write to it, and then once you close it, it will bring what input has been put to it and to a disk. So let's take a look. So we have a demo here. So suppose I want to write a console-based text editor, which sounds complicated, but it's pretty simple. What we want to do with this text editor is we want to read input from user. And then as long as user has some input that is not an empty string, we'll just keep reading input. And then once user enters something like empty string, the program ends, and we want to save the file. So what we need to do is, first thing is we need to declare and initialize the stream writer object. And then we keep reading input from user as long as the input is not an empty string. Once the input is an empty string, we will stop reading input and end the program. And after this while loop ends, we will want to close the stream writer object and let the operating system create the file for us. So, what is this? Oh. What does it look like? I have something here called fwrite demo, and I'll say let's say I want to create a file called hello.cs. What I will do is I'll write something like this. What we have done so far, what we have done many times. Write a simple program here. What is that? Hello, and then public void main console.write. Hello world. And then if we enter something like empty input, the program ends. And now you see there's a file that we just created. And will this program run? Of course, if I compile it. It compiles, and you see it's here. We can run it. It works. So the idea is simple. We just read the input and we save it as a hello.cs file, and we just compile and run it. The program will be, the whole input will be treated as a normal CS program, and everything will work. What does the program look like? So again, I use the command line argument to receive the input, the file name that I want to create. And I create stream writer object. And then I declare string variable for receiving and storing the input from user. And also I have this line number counter here, kind of a feature to count how many lines we have written so far. And I start with a do while loop. So what we do is I print this prompt, which is line, and I plug in what the number is, whatever the line number is, and I read the input from user in the console and assign to this string variable that we declared. And if it's an empty string, we break out a loop. We just jump out of the loop, stop reading input from user. Otherwise, we use this stream writer object to write this whatever input we had to the file that we just created, which is new stream writer app name. And at the end, we'll increment the line number so that the next time we write an input, the number will increase here. So after that, we close the file stream writer object, and that's it. So we print out the prompt, read it, I enter the input, and because it's not an empty string, we print more prompt until we enter something empty string, and then the prompt ends, and the file will be saved on disk. Okay. Any questions? All right. So I have a question for you guys. What's the difference between console write line and stream writer.write line? What's the difference between them? Where do they each write to? Are they writing the same thing? Okay.
That's that we will write to the disk, so we'll save.
Yes. So console write line writes whatever you gave to it, which in this case we have hello world, to console. Stream writer write line writes this in whatever you pass to it, in this case hello world, to a specific stream writer, which is a file, which corresponds to a file on the disk. So here's the thing, console is a file. Like I said before, everything on computer is a file. Console is a special file that is owned by the operating system, that is not controlled by you, and you can probably not modify it at all. And when you read input from console file, you use the console.read line to receive the input from console. And we try to give something, when try to write output to a console file, you use console write line instead of a stream writer write line. And the difference is console is the standard I/O for a computer. Well, as stream reader and stream writer are just files that are on the disk that is not related to the system and the computer. Okay. Of course, this is just some extra information. I don't think you will need to understand or memorize it for the exam. Now we're going to talk about paths and how do we find a file in the computer. So files on computer are saved in directories, and also known as folders. So every file on computer must live in a directory. It cannot be like independent from the directory structure at all. A directory is a special file that does not contain anything, but links to other files that is in the directory. So therefore, directory can be linked to directories. That's why when you open your home folder, let's say I open this folder, I'm in this folder, home folder. I see all these folders or directories. They are files, and they are linked to different files. If I open this document, folder, or file, it's linked to those files. However, directory cannot be read or write. You can only read or write a file. Another thing, and then when the program runs, there's a thing called current working directory, which means that the program is invoked in that directory, and that is program where program will get data and run things by default. Programs can directly refer to the files in current working directory. If you want to use files that is not in the current working directory, you need to use either absolute file path or relative file path. Okay. So here's how a directory structure looks like in computer. So this is mostly in Mac and Linux. Windows has similar structures, but not exactly the same. So we start from the very fundamental directory called root directory. And then these directories such as bin, dev, and sys are for like system directories. Most of your personal files are stored in this home directory. And for this particular computer, there are two users, user A and user B. They each have their own like documents, like videos, music folders, and suppose they also have, for each of them, they have this bin and source directories, and they have their own programs in it. So in order to refer to a file, we need the path. So there are two ways to refer to the file. We have the absolute path and the relative path. So for absolute path, we will always start from the root directory and goes to the file. So for instance, if I want to refer to program A.cs using an absolute directory, absolute path, we need to say /home/user A/documents/source/program A.cs. Very long, but it's an absolute path. It does not is not dependent on the current working directory of the program. Any program can use the absolute path to find its file. Relative path is a little bit different. So for instance, if I run this program A.exe, in this bin directory, and then I want to access data on this directory, what it will need to do is it will need to go up to the directory to documents / and then go to this, and then go down to this source / directory, and then find this program A.cs file. And the advantage is it does not have this long path, absolute path name, and it's not dependent on the structure of the rest of the things. It only depends on this relative path, relative part. Most applications use relative path to refer to a file internally. Otherwise, it's going to cause the more chaotic problems in your system. So, how do we find a file path and working directory in C#? It turns out that there is a, oops, probably not this one. In C#, you can find the current working directory of the program by using directory get current directory directory dot get current directory method to find out where the current working directory is. So for instance, right now I am in this directory, home, yho, insync, Loyola file, and also wait like one demo. So if I invoke the program that I wrote, which is current directory.exe, it will give me this directory instead of this directory. So because I invoked this program in this directory instead of where this program is saved. So if I go to the bin directory and then I invoke the program again, it will tell me that the current working directory is here. You see there's a /bin, means that it's invoked in this directory regardless of where it's saved. So now we go back to our examples and see how we can find a file, because your next project, future projects, you're going to use locate those files in your directory and read them and calculate things. And it's important for you guys to understand how this file structure, directory structure works, so that you know where you should refer to those files. So let's say we go back to our file read demo. If I want to use the file read demo to print out this file from this directory, what we need to do is we need to go up one level and then go to the source directory and then find the file using this relative path, and we can print out the content of this file. How do we do it in the absolute path? What we will need is, instead of going up and going to the sister directory, we'll need to start from root, go all the way to this file, one demo source array. They're printing the same thing. This one is easier and more likely you guys are going to use this way to locate the file in your project in the future. You can do it this one, but it can be tedious. First, it can be tedious. Second thing is, if your program use this kind of path to refer to the file, and then if you copy your program to a different computer and didn't change this file path, then you will never find this file, right? So in this one, it's not dependent on anything but this small directory here. This path is dependent on the system, so you would not want to do that unless you really have no choice. Okay, do we have anything else to say? So a little bit summary here. So we reviewed array and its operations. We know array has a fixed size. You cannot change its size during runtime, or you cannot resize it, but you can reassign it. We learned a little bit about the difference between memory and disk. Memory is fast. Disk is large. I mean, in terms of capacity. And we we know a little bit more about files. So how files actually looks like in the operating system in the disk. And we learned how to read and write a file, especially for the text file, using stream reader and stream writer object. And we also talk about current working directory. So it is where the program is invoked. It's not where program is stored. And we also talk about relative and absolute path. That's how you first find a file in the directory. All right. Do we want to have this bonus topic? Do you want to do lab or bonus topic?
Bonus topic.
Okay, cool. So, here's our problem. Everything comes with a problem. What if file that we want to access is currently used by the other programs, or it does not exist, or it's protected by the operating system that you cannot use unless you are the administrator of that computer, or it's on some remote machine in the network and the connection is broken. In another word, you cannot access the file, and you don't know that when you write the program. So, for example, if I say a typical example is the file does not exist, and you don't know that when you write the program, what should you do? What can you do based on what you have learned so far? You can use an if-else statement, right? You say, if the file exists, we can do something. Otherwise, we won't. Sometimes that works, but sometimes doesn't. In those cases, it doesn't work. What happens is that the program will crash. If you have more work need to do in the later part of the program, whoops, all the work is gone, you have restart, and unless you fix the problem, and which in this case it's not easily to be fixed. So what can we do? We use an exception. So unfortunately I don't have those demos files because I deleted them somehow. What is an exception? So for instance, let's do a simple case. Let's say common problem, divide by 0. We do something like this. Oops. And A equals to in. So let's say we read 2 inputs from user and assume that they are integers. And then we want to print out the quotient between of them. So oops, something's wrong there. Oh, okay, I didn't have them. Void main. Okay. Okay, so let's say we want to run this program. We enter 8 and we enter 0. And you see the problem here, unhandled exceptions. If you ever notice your program, like when your program does not compile or your program runs weird behavior while the program is running, you more likely to notice this message, and you probably don't understand what it means before. But now it says is that it's an unhandled exception, means that, and the exception is divide by 0 exception, and it's in the system part. So C# is known. C# knows that you're trying to divide a number by 0, and it does not know how to deal with it. So what happens here is that the program throws an exception, and it's not handled by us, so the program crashes. And similarly, if you try to access a file that does not exist on disk, and it will throw a similar exception, and the program crashes. And if you have any work you want to do, let's say, where is it? If I have something like some other code here, and because b is 0, so the program will crash when it executes this line. So nothing here will be executed, which is not what we want. So what can we do? We can try it. We'll try, say, okay, we assume that it's a legit number, but we don't know what it is. And then in case those exceptions happens, we say we catch the exception. So in this case, we want to catch the exception, which is divide by 0 exception. By 0 exception. And when we catch that exception, we'll say, oops, you entered a Lego number. Alright, so now if we try to run this program, and we do the same thing, we try to divide 8 by 0, instead of crashing, the program actually print out, oops. That means, even if you give a wrong number here, if you give a 0 here, and this part doesn't work, the program will not crash. It will catch this exception, which is divide by 0 exception, and print out this error message. And if you have anything important here, the program is supposed to run, it will still run. So this try catch exception handle method helps you to prevent unnecessary crash of program. And of course, this is a bonus topic. You're not required to learn it, I guess. I don't think it will be an exam either. But if you're interested in this, I encourage you guys to explore it more. Okay. That's it for today. Catherine, do you want to do lab?
Oh, yeah, yeah.